In this video I'll demonstrate the intersection of three planes at a point that is a unique solution. This diagram shows the x, y and z axis. We have x coming in this direction and a scale across the bottom here. The y-axis is here and there is its scale, and vertically we have the z-axis. Now the first plane I'll graph will be y equals 0. And next I'll graph the plane z equals 1. And we can see those two planes currently have a line where they meet along here. Next I'll plot the graph of x equals -1. And we can now see that those three planes meet at a common point here. And we can find that point using this program. And there it is marked in yellow. Now we'd expect the coordinates of that point to be x equals -1, y equals 0 and z equals 1, which is what the program is telling us, although -0 is a bit of a mistake. Now we'll look at three planes that intersect at a line, which will give us a unique solution. The first plane I'll graph will be x take 2y plus 5z equals 1, which we have here. The next plane is 2x take 4y plus 8z equals 2, and these two planes meet at a line which we have along this length here, and we shall calculate the equation of that line. There is the line, and its equation in vector form is over here. Now I'll graph my third plane, which we can see intersects the other two planes at that line. So all three planes here intersect at a line and therefore have infinite solutions. Now I'll construct three planes that have no common points of intersection, and the three planes will not be parallel. My first plane will be x plus z equals 2. Next we'll have x take y equals 3. These two planes intersect at a line along here. And my third plane is y plus z equals 5. Now we can see these two planes meet at a line and these two planes meet at a line, and we'd assume that these two here would eventually meet at a line up here. And let's just change the view. Alright, now we can see all three planes are interacting with each other in pairs, but at no point do all three planes meet at any common points. So we have a line of intersection here, a line of intersection here between two planes, and another line of intersection between two planes. But once again, nothing common for all three planes, therefore no solution. Now finally, we have no solution if any planes, be it 2 or 3, are parallel, which I'll demonstrate here. Here is x minus y minus z equals 1. and if I have two other planes with the same coefficients of x, y and z, they'll be parallel. So x minus y minus z equals 3, and x minus y minus z equals 7. So all three planes parallel, no solution. Now if we have two parallel planes, I'll introduce a third plane that's not parallel. So x plus y plus z equals -3, so the coefficients of x, y and z are now different, and we can see there is intersection between two planes, but at no time will the three planes have any common points, as you would expect if you have parallel planes. So no solution.